Hi, I'm Danielle Robinson and I'm a second year PhD student at Newcastle University. Today I'm going to talk to you about an aspect of my project which looks at drivers of reef shark abundance and spatial distribution. Sharks are apex predators and they play an important role in the ecosystem by maintaining species below them in the food chain. Declines in sharks can disrupt key ecosystem services, including fisheries, food and tourism. On coral reefs, declines in shark abundance can cause an increase in other larger predatory fish, such as groupers, which can then increase predation on herbivore communities. This can be a problem as herbivores are considered key to reef resilience and recovery, especially following impacts such as coral bleaching. Sharks are in decline globally, however, and it's estimated that around 100 million are killed annually. This greatly exceeds the average rebound potential of most shark species. 25% of all shark species are at an elevated risk of extinction, and a further 50% are data deficient, which means we don't have enough information to assess their vulnerability. Marine protected areas and shark sanctuaries are a key spatial management tool to protect sharks. Globally, more than 3% of the ocean is protected exclusively for shark conservation. However, such measures are often implemented without prior knowledge of the behaviour or spatial distribution of the species that they're designed to protect. Effective shark conservation urgently requires a greater understanding of shark abundance, distribution, and the key drivers of this distribution, to assess the risk of key threats such as overfishing, habitat degradation, and climate change impacts. My study was conducted in Maldives, which is a unique oceanic atoll system and a country known for its high dependence on marine resources, both for fisheries and for tourism. Field work was conducted in North Malé Atoll, which is found on the right-hand side of the Maldives archipelago. Commercial shark fishing began in the late 1970s in Maldives, and it primarily targeted three different fisheries. These were the deepwater gulper sharks, reef sharks, and pelagic sharks. The deepwater gulper fishery collapsed within a decade, but reef and pelagic shark fisheries continued to expand until their peak in 2004. Ongoing declines in shark abundance and growing conflict between the fishing and tourism sectors led the Maldives government to declare its entire exclusive economic zone a shark sanctuary in 2010. Like many other remote island nations, this was more of a precautionary last resort due to the lack of baseline data available in the region. The first aim of the study was to quantify patterns in shark abundance, and for this we used baited remote underwater video, or BRUVs for short. What that is essentially the main image that you see on the slide there. So we have this metal frame which is lowered down onto the reef between around 10 and 15 metres. Inside the frame we have a GoPro, and extending out is a PVC bait arm with around 1 kilogram of bait in the end. The idea is that this system will attract any sharks in the nearby vicinity. They can be quite curious, so they'll often swim towards the bait, and then you can capture them on footage. From this you get a good understanding of abundances, which species are most common, and you can also look at areas of high and low abundance across the survey area. In total, we've deployed around 230 of these BRUVs across North Malé Atoll. They're all left underwater for around 70 minutes, and when we analyse the data, we record the max N, which stands for the maximum number of a single species in a single frame at any one time, and this just ensures that we're not recording the same individual as they swim back and forward in front of the camera field of view. To give you an idea of what we see, these are some of the underwater highlights. BRUVs were chosen as they have a number of benefits over traditional capture-based survey methods. They're non-invasive, non-destructive, and they also cause minimal damage to the benthic environment. They're also a common approach to record larger, more mobile marine species or species which can be quite secretive, and this therefore allows us to compare our findings to many other regions around the world. In total, 197 sharks were recorded from 8 different species. Sharks occurred on 65% of all BRUVs deployed, with a maximum of 7 sharks on a single video. Mean shark abundance was 0.78 sharks per hour of footage. The most common species recorded were blacktip reef sharks, nurse sharks, and whitetip reef sharks. These are all classified as near threatened on the IUCN Red List, as are grey reef sharks, tiger sharks, and lemon sharks. We also recorded one individual silvertip and silky shark, both classified as vulnerable. Taking the data from the BRUVs, we can map out areas of high and low shark abundance across the survey sites. This can be an important management tool as it allows us to easily visualise locations which may be more important to sharks and identify important habitats. I have broken this down by the 3 most common species recorded, including blacktip reef sharks, nurse sharks and whitetip reef sharks. But I think the key message here is that areas of highest shark abundance was the same for each species. And this is the red-orange colour that you see in the centre of the survey area. This area actually surrounds a couple of resorts. And under regulations for the Maldives Tourism Act, resorts are able to ban extractive activities, including fishing, in a radius of 500 to 1,000 metres from the island. So these reefs are actually have an additional layer of protection. Sharks, as well as fish communities and the benthic habitat is protected. So they're almost these de facto marine reserves for sharks that have been in place a lot longer than the shark sanctuary itself. When we compare our findings of shark abundance to other regions around the world, we see that the Maldives is very much in line with locations that have also implemented marine protected areas and shark sanctuaries, such as Indonesia and Fiji. They're doing a lot better than heavily fished locations like the Eastern Red Sea. There they recorded less than 0.01 sharks per hour of footage, but they do fall behind regions of the world deemed to be unexploited. So locations such as the Solomon Islands or New Caledonia, where they record up to 2.5 sharks per hour of footage. Second aim of the study was to identify the key drivers of shark spatial distribution. For this, we used underwater surveys and dived at 50 sites across North Malé Atoll, surveying the same locations where the baited remote underwater video had been set. Surveys were designed to be really rapid and we wanted to cover as large a spatial area as possible. So we conducted one 30 by 5 metre transect at each site, and we recorded key aspects of fish and benthic community composition. The fish were broken down into key families known to be shark prey, with individuals recorded and size estimated. We also did a timed roaming survey to account for fish species richness. Benthic substrate was recorded every 50 centimetres along the transect and broken down into broad categories including live coral cover, rock, sand, rubble, algae. We also recorded coral growth form and structural complexity. All of the data from the BRUVs and dive surveys were put into models so that we could assess the relationships between shark abundance and environmental variables. I compiled models for all sharks combined and then broke down models for the most common species recorded. All sharks showed a positive relationship with herbivore biomass and lower trophic level predator biomass. As well as being potential prey for sharks, herbivores are an important functional group on coral reefs. They do help to keep the benthic substrate free from algae and promote coral recruitment, while predator biomass is a good indicator of fishing pressure. Blacktip reef sharks were primarily driven by distance to the edge of the atoll, so they were much more common on inner atoll sites that are more protected and sheltered, as well as herbivore biomass and again lower trophic level predator biomass, while whitetip reef sharks showed a positive relationship with herbivore biomass and live branching coral cover. It is important to note that all of these surveys were conducted post-coral bleaching disturbance. In 2016, the world was faced with the longest and one of the most severe coral bleaching events ever recorded. A lot of the reefs that we surveyed in North Malé had shifted from this healthy to a degraded reef state, and they were dominated by rock, rubble and algae. This could explain why we didn't see clear relationships between benthic substrate, fish communities and shark abundance, or it could be due to sharks being highly mobile and not so dependent on the reef substrate itself, but more what it can support in terms of fish biomass. Key take-home messages of the study to date suggests that shark populations may not have yet recovered from fisheries exploitation prior to the 2010 shark sanctuary implementation. We don't have long-term data to compare our abundance values to, which can make it quite difficult, but we can look at other regions around the world, and this suggests that shark populations in Maldives are relatively healthy. They are doing a lot better than heavily fished locations and are in line with other regions that have implemented shark sanctuaries, but they do fall behind unexploited regions of the world. Findings also indicate that prey availability is very important to shark abundance and distribution, and this is something that we commonly see across both terrestrial and marine environments. It does, however, suggest that we may need more of an ecosystem level approach to conservation rather than species-specific bans. as if we're not protecting what the sharks are dependent on, this will likely have a knock-on effect on the sharks themselves. This could be particularly important in light of the reef fishery expansion in Maldives. As they continue to build and develop more resorts, there's a greater demand for reef fish, which brings me on to my final point in that we really need to start looking at overlap between key shark hotspots or areas of high abundance and common fishing grounds. Thank you all very much for listening. I will be very happy to take any questions that you might have. Thank you.